Let's walk through a covariance calculation together so that you can see step by step what's at play. Once again, we're taking ordered pair by ordered pair. We're looking at the deviation of X from its mean, Y from its mean for each ordered pair. We're taking the product of those deviations, we're adding them all up, and we're dividing by the number of observations. Now, we're going to be looking at a sample, and just like we saw with sample standard deviation versus population standard deviation, we're going to divide by n minus 1 as opposed to n. But aside from that, it's going to look just like this population covariance formula. Let's hop in and take a look. Lines on Clay users, we're going to have you do an exercise very much like what we're about to show you. Head over to File, once you've clicked the link to this Google Sheet, make a copy, and then you'll be off and ready to go on your own. Everyone, we have already shown you these data pairs, right? We've got US stocks, weekly performance, and international stocks, weekly performance, US volatility. And then how did US stocks do this week versus how did US stocks do last week? And we saw this was US stocks against international stocks, very nice relationship where it's a positive relationship. We see US stocks versus US volatility. When US stocks do well, when they go up, volatility tends to go down. And when stocks tend to go down, volatility goes up. And then there's really no great relationship between how did US stocks do this week versus last week. We can have good weeks paired with good weeks paired with bad weeks paired with bad weeks, or bad weeks paired with good weeks. Great. Okay, let's calculate a covariance together. First thing I do is I've got the mean weekly performance for the dates in period. So for the 10-year period that I looked at, we have a mean weekly performance in the US stock market of almost 0.25% per week, which is actually quite good, by the way. And in comparison, international stocks did not nearly as well. They did 0.08% per week. So these are the average weekly performance, and these are samples, right? We're working off of one particular 10-year period. Well, let's calculate these together. First column that I have here is really just the duplicate of what we saw over in column B. And the same is going to be true when I look at my international stocks. How did they perform? And that's what's going on here. Now what I've done is I've just asked, how did they deviate from the mean? So I look and, hey, I've got this mean column that stays the same, right? It's 0.23 every single value. And what I'm asking is I'm taking the individual deviation. So how did the US stock market perform minus the US stock market weekly mean? And that is what this column M comes out to. Well, similarly, I have a column where I'm just looking at the international stocks mean, and then how did the international stocks deviate? So in this one particular week, week 1, the US market performed 0.23% below its weekly mean, and at the same time, the international market performed 0.32% above its weekly mean. The next week, the US market performed 2.91% below its weekly mean, and in that same week, the international market performed 2.5% below its weekly mean. In this last column, we're just taking the product of deviations. In other words, okay, negative 0.23 times positive 0.32. And when you take a small number times a small number, you get a small number. And so we get negative 0.0007 for that particular product. And we now have a column of the product of deviations. How did X deviate times how did Y deviate for each and every week? Now, once we have that column, that product of deviations, from there, it's just taking an average. We are adding up all the values in this particular column, and you can see these are a lot of small numbers, right? So that sum is going to turn out to be a small number as well. And that entire sum for 10 years comes out to just 0.239. We are dealing with a sample, and so we're going to work with n minus 1. We had 523 observations, so we're going to work with 522. And we take the average by saying, well, what's 0.239 divided by 522? And we come up with a small number, 0.000457. I will point out it's a positive number, and if you wanted to just do this much much more quickly in Google Sheets or Microsoft Excel. You could say equals covar and then parentheses, and in this case, just highlight column K, which was the US stock performance, and column N, which is the international stock performance. Notice that it defaults to sample covariance, not population covariance. But those values more or less are exactly the same. There's just a little bit of rounding error. One question that we might have, well, how many times were the products positive and how many times were the products negative? Remember, we're saying that there is kind of an overall positive association between these two asset groups. And we see that of all the times that we made an observation, 410 times the results came out to positive, or the product of the deviations was positive, and 113 times the product was negative. This is one way of looking at our deviations and how they pair, the US deviations in this darkish color and then the deviation for international in orange. And here we have week by week what were the product of deviations, and we can see most of these are above the 000 line. We have a couple big positive deviations in relative terms. We are going to have you do the same thing step by step, but we're going to have you work with the product of deviations for volatility. Remember, you should end up with a negative relationship between these two data series.